Hi guys, this might be your most important maths lesson ever. In electronics and computer science and physics, we have to have a certain understanding of maths, or we are going to get very frustrated very quickly. So today we are going to simultaneously solve two equations, one of which is quadratic. Now, these two equations result when we're trying to calculate biasing for the enhancement mode MOSFET. But don't let that stop you, because these type of equations are extremely common and it's important that you understand. As you look at the two equations here, K, VTH, and RD and VDD are all constant values which you know. The things that you do not know, the unknowns in this equation, are ID and VGS. So those are the two unknowns. So the first thing we have to do is to make ID the subject of equation 2 and then substitute equation 2 into equation 1. In order to do that, we will give you some steps. We are going to give you all the baby steps to get that done. But the reason why we are doing this is because we must eliminate ID entirely, because the equation is quadratic in VGS, as you will see momentarily. The action of making ID the subject is also referred to in mathematics as isolating ID. So we start by multiplying by -1. We can multiply throughout any equation by -1 to change the signs, and this will make it easier to see. So we just change the signs on all the terms, and then we add the VDD to both sides. So the VDD moves from the right to the left. Then all we need to do to isolate ID is to divide by RD. And there we have our ID, and we can now substitute into the other equation, substitute into 1, so that ID is completely eliminated. The next step is to make the left side equal to 0, because the quadratic equation must equate to 0 for the formula to work properly. So in order to do that, we're going to have to move RD, VDD, and the minus VGS over to the right side of the equal sign. It's easy to multiply by RD to get rid of the denominator, and it's just as easy to subtract the VDD and add the VGS to bring the other two terms over. The next step now will be to expand the square and multiply it out, which is actually called distributing the brackets. Finally, we have to do that again to get rid of the larger bracket and to distribute the RDK across the three terms inside there. So now we have 5 terms in the expression, all equating to 0. So the next step we want to do is to collect terms that are alike. We see that we have 2 terms in there with VGS. So we have to incorporate those two terms, and that collecting it up leads to the 1 inside the bracket, because that is saying we have 1 VGS minus 2 RD K VTH VGS. When we rearrange our expression and bracket it in the familiar way, we see that we have a quadratic equation in VGS with the familiar A, B, and C to use in our quadratic formula. Now, when we do this, when we plug in the values, which are all constants inside of the A, B, and C, and we calculate S1 and S2, which are the two solutions of the quadratic equation, we will usually find that 1 is positive and 1 is negative. We have to always take, in the case of the enhancement mode MOSFET, the positive term, because VGS is always positive in an enhancement mode MOSFET. In the event, rare event, or almost impossible event that you should end up with 2 positives, I can assure you that only one of those positives is going to lie within the permissible range of VGS. So it will not be a problem for students of electronics to reach this stage and to select their particular value of VGS. Once they have selected their value of VGS, it should be a small matter to plug it back into this equation here. VDD minus VGS, and divide it by the value of the resistor RD, and they will get the suitable value of ID, which corresponds to that particular value of VGS. Thanks for watching, and we hope to see you in the next video.